So we've just talked about simulations, and now we're going to switch gears a little bit. Simulations, we looked at percentages given to us that happened in the real world that we said, hey, we don't want to actually do this in the real world. Let's simulate it. Let's take a look at what could happen and find out what our outcome would be. Now we're going to look instead at sampling, and sampling is where we're going to actually reach out and talk to people to ask them questions or give them surveys, gather data in that way. So there are three big ideas behind sampling, and we're going to look at each of those in greater detail in the upcoming slides. But the first is that we're examining a part of the whole, which is what we call the sample. So the part is the sample, and the whole is the population. Now, when I say population, I mean the population that we're studying. So it doesn't have to be the population of the world or the population of the US or the population of Nebraska. It's the population of the people we are studying. Idea 2 is to make sure we randomize because it ensures representation of the population, and we'll talk about that in great detail. Idea 3 is the sample size. We want it to be big but not too big. Sorry for no comma there. Big but not too big. So idea 1 is to examine a part of the whole. So again, our goal is to learn about the population, which is the entire group of individuals that we are studying. However, sometimes it's costly or impossible or just far too time-consuming to collect data on the entire population. That's why we only have a census every 10 years. Instead, we collect data on a smaller group of individuals called a sample. And the sample is representative, so it's pulled from the population, and we feel that it's representative of the population. And we'll talk about how to make sure that sample is representative in another lesson. So methods used for collecting data are surveys, which is what we're going to focus on here, sometimes called sample surveys, but there's also observational studies and experiments, which again we'll look at in our next chapter. So remember that we want a sample that we feel represents the whole, the population. And I've given you 4 scenarios here, and I want to talk about whether or not these would be good ways, which will sort of get us into bias, which is what we're going to talk about in this lesson, but it'll be a good preview to bias that we will talk about in another lesson. So first, if I asked a certain number of volunteers to give their opinion, would that be a good sample of the population? Well, in this case, no, because typically what happens when you ask for volunteers are people with really strong opinions are the only ones who are going to respond. So when you get to the end of your college term and you get sent the 18 emails that say, please send out this, or please fill out this survey, if you loved your teacher and thought he or she was the best thing ever, you take the time to fill that out because you're so appreciative. If you hated your teacher and thought that he or she was spawn of the devil, then you make sure to fill that out so that everybody knows how despicable of a person your professor was. So it's always people with strong opinions one way or the other. What if I decided to give an English class at the school the survey? Well, this one's maybe okay, but if you remember back to high school, and that might be a few years ago or it might be a few decades ago, many English classes are based on grade level, so 9th grade English, 10th grade English, etc., and it might not be representative of the population. Set up an online poll that students can take. Would this be good if I'm trying to find out if students like the food served in the cafeteria? Well, this might be good. It kind of depends on the school, but it's voluntary, which means, again, not so great, and not all students have access to the internet. So again, that's the depending on the school thing. Obviously, if you're at Bellevue University, you're probably taking an online class and should have access to the internet. And maybe not everybody checks their school-sponsored email, which is maybe where that survey would come through. Ha ha. And last one, have students take a quick survey in the cafeteria by a show of hands. So a lot of people in my classroom say, yes, this one's okay. But again, this one's not okay because students are often influenced by friends. Getting an accurate count would be difficult. And also, people who are in the cafeteria maybe actually like the food in the cafeteria, and so they would be, more apt to say that the food was really good. So what do these situations have in common? They all have a form of bias. So bias occurs when our sampling methods either overemphasize or underemphasize some characteristic of the population. So how do we eliminate or reduce the bias? One way is through randomization. So that is idea 2, is to randomize. So again, it would be time consuming and futile to try to list all of the characteristics of a population. Age, race, ethnicity, income, marital status, etc., 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 and then try to represent everyone equally. However, if I choose a random sample, something that's completely random, then I would assume that all of the characteristics that I had in my population would then be represented in my sample as well. For instance, here is a table that shows 2 samples, each that are 8,000 randomly selected customers of a company. Do I feel like the samples are representative of all customers? So do I feel the sample is representative of the population? Well, what I notice is that there are some small differences, but if I look in each category, these numbers are really, really similar. And because the numbers are similar, then we can say it is reasonable to think that these samples represent the population. The last idea is sample size, and this one a lot of people struggle with because if I need 100 students at Bellevue University to get a random sample, how many Americans would I need? Well, I still only need 100. What we need is enough to be able to have varying opinions or varying answers, etc. But not so many that it's going to cost a ton of money or that it's going to take a ton of time. But just so we remember that terminology is important, remember this would be considered, a sample size would be represented as N, which is the number of individuals that we speak to. So we'll talk more about that in a little bit, but just know sample size is N. So again, the right idea is to find a good balance between the number of people being surveyed and the cost of the survey. So if you have too few, you won't get a good sample, you won't get good results because there is not enough of a difference of opinion for us to know what to expect in the larger population. If you have too many, it's going to take too much time or too much money. A census, more vocabulary, is when we talk to everybody in the population, which obviously is ideal, but we've got some problems when trying to do the census. It's pricey, both monetarily and in time. It's difficult or impossible to find everyone in the population because people are often moving, moving jobs, moving states, moving houses. The population is always changing with births and deaths. Sometimes college students are counted doubly or possibly not at all. Those without an address or who are not properly documented are not counted as well. So again, there's a lot of issues with doing a census, which is why some of these other methods that we're going to explore together might be a better way.